Yeah, drop, hey, huh.
Yo, what's up guys, this is 𝗙𝗘𝗟𝗟𝗟 and today we're playing SaaS from PicoCTF, another binary exploitation challenge, and we see shellcode as a service, okay? I haven't solved this challenge, so let's blackbox it. We download the files right here and we see we have 𝗙 and 𝗙.c, don't forget, 𝗪𝗟 plus 𝗪 to make it executable. And let's view the source code. Right here we have a size of 0x100, okay, that's really nice and big. And after that we have this assembly. Let's see what it does. So assembly to code. We go here and paste it, convert. And what it actually does is sets up the registers and then it clears them, okay. Back to the source code, we see we have a flag size of 64 and then a car flag array. Below here we see load flag, which opens flag, okay, that's nice. And after that we see a setup function with seccomp filters. So what is actually seccomp? Let's say it's a restrictive tool or one that gives permissions. And this allows you to execute only some certain syscalls. And right here we see write, exit and exit group. If you try to execute something else, the program will exit. And if we didn't have the source code, we can actually see it like this, seccomp-tools. Oh, we need to create flag.txt. And if we do seccomp-tools dump and our challenge, enter something, and we see here we only have exit, exit group, and write available to us. So this is what we're gonna do. We have to actually abuse one of these three. Exit and exit group is pretty much useless to us, so we have to play with write. And let's go inside the debugger and see the challenge. So we run seccomp and we see that there is no canary and X is enabled and PIE is enabled. This is gonna be tough because we don't know the addresses of flag or load flag or something like that. And if we go below here, okay, nice, we see an X is enabled, but we don't care much because right here it sets a void pointer address and actually makes it executable, and after that it will execute whatever is on this address, so we can execute code on the stack even though an X is enabled because the program itself made this executable. Let's see, if we print flag, okay, we see that it's at this offset. Let's make ASLR on, ASLR is on, okay, and if we run it, we see that flag is actually at this address. I'm gonna save it here. We run it again and we see right now it's at this address. And one last time, I promise. What can we see here? We see that these are randomized and the last ones are a constant offset. Our goal here is actually to brute force this address in order to leak it with write. So we have this address are the constant, so we'll start brute forcing this in order to try and leak the flag, and our goal should be something like that. Write 1 and the address of flag, and we know it's 64 bytes, so something like this. If you don't remember, if we go here, Linux, if we go at this side, we see that in order to call write syscall, we need rags to contain 1, and then RDI, you know, we want std out, and then our flag address, and then RDX. So let's start creating some assembly here. And first of all, let's initialize this. We're gonna move to RSI the fake base address we have, so something like this, but we're gonna have this base right here. And then we're gonna set up the rest for our syscall. Move RDI, we want 1, and move RDX, we want 0x40, which is actually 64. And then we're gonna loop around our program. What we need here, we want rags to have 0x1, as we see from the system call, and then we need to add to RSI this offset here, so we start brute forcing, and then syscall, so it will print it out to us. And last but not least, we need to jump again back to loop. So this is actually the assembly we're gonna use. Let's see, try r.send line, and we need to send our shellcode and print r.rectLine contains pico, because we know the flag starts with this. If so, then close the instance and we're good. Otherwise, print. Unlucky, bro. This should be enough to get cell, and let's try to run the solver remotely. Python solver, yeah. Try accept, let's try. And we see that we didn't manage to get the flag right here, and that's because I messed up with the assembly. We have RDI here, let's try again.
A few moments later.
And we see that we finally managed to get our flag by brute forcing the address of flag. That was a challenge, guys. It was really nice. I really enjoyed it because I like writing assembly in Pwn challenges. If you have any questions, leave a comment so I will reply. If you found the video useful, leave a like and subscribe to the channel to support me. And have fun and see you in the next video. Bye!